In this recording, we're going to look at vertically stretching or shrinking, or possibly even reflecting, sine and cosine graphs. You're going to need a piece of graph paper. So get yourself a piece of graph paper, write this heading on, and then once you've got the heading written, let's play the recording. All right. I'd like to get your graph paper, and the first thing I'd like you to do is in the middle of the graph paper, approximately, I'd like you to draw a horizontal x-axis. And then I'd like you to set up the axis the same way we did when we graphed one cycle of y equals cosine x in the domain 0 to 2 pi. Okay? Then I'd like you to play the recording once you've set up your axes. Okay, so hopefully you've set up your axes. Looks something like this. We're using a 4 to 24 ratio. In other words, we're going out from the y-axis 24 boxes to the right, and we place that at 2 pi, because 2 pi is around 6-ish, around to the nearest whole. And if I'm going up 1 is 4 boxes, then I need to go out to the right 24 to represent 6 boxes. Okay? We're going to transform some trig functions. We're actually going to extend out our y-axis to accommodate some stretched out graphs. Okay. So what I'd like you to do now is actually stretch out your y-axis, and every 4 I'd like you to make a mark. So keeping the same ratio, but every 4 boxes, we'll call that 2, 3, and 4 will do the same in the negative direction. Go down 4 boxes, 4 boxes, and 4 boxes. Hopefully you have enough space to make this happen on your graph paper if you put it in the middle. Okay. Okay. So the first function we're going to graph is y equals 3 times the cosine of x. All right. Let's get a basic cosine graph, and then we'll graph 3 times the cosine graph. Okay. So let's back it up. This one's on your own. Pause it, and then play the recording once you've graphed cosine of x. All right, so hopefully your cosine graph looks like that. You're getting to be a cosine graphing pro at this point. We're going to stretch this graph out. We're going to put a 3 in front. And so what we remember from transformations is if we put a number, a coefficient in front of the function, it stretches the graph out. Let's look at our graphing calculator and observe what happens when we put a 3 in front. So let's go into y equals. Let's put in 3 cosine of x. If you don't have a calculator, you can just look on with me. If you have your calculator, you should do it yourself. We're going to hit zoom and then Z trig, choice 7. And that's 2 cycles of cosine. You can see that the cosine normally would be here at 1, 0, -1, 0, 1. That's what you just graphed. This graph has the same x-intercepts, but it's stretched out. Each of those y values, this one instead of being a 1, got tripled. This one instead of being a 0, oh, it's still a 0. This one instead of being a -1 is -3. The 0 times 3 is still 0, but the 1 times 3 moves up to positive 3. So it stretches all the y values by a scale factor of 3. Let's go over and make that graph on our sheet. Okay? So for this one, every place I see a 1, like right here, I'm going to make it a 3 because it's 3 times as big. If I see a 0, 0 times 3 is still 0. When I see a -1, -1 times 3 makes -3. Back to 0. And at 2 pi, we're up to positive 3. Okay? Do your best to connect those dots and then play the recording. So at this point, we've got two functions on the same axis. You can see that we've stretched out our cosine graph, vertically stretched it. I need to label both functions because anytime I have more than one function on the same axis, we need to know which one it is. So this one I'm going to call y equals 3 cosine x. And this one is our base function, our parent function if you like, y equals a cosine of x. Hopefully you're using a pencil. Anytime you're graphing, you want to use a pencil. If you want to make changes, if it's not quite curvy enough or perfect, come back and fix it. Okay. Next function I'm going to look at is negative 4 cosine x. You should have in your idea what would happen if I multiply each one of those ones and negative ones by a negative 4. So if I multiply this 1 here by a negative 4, hopefully you realize that's going to affect it in a negative way. That's going to take it down to negative 4. If I multiply the negative 1 by negative 4, that's going to make it a positive 4. So it's going to have a reflecting property. But we can check that out real quick in our calculator. Let's go over here and delete that. And instead of having a positive 3, let's put in a negative 4. Now again, I'll hit zoom 7. Okay, so our base function was here. That's our cosine graph, but everywhere we have a positive 1, it moved down here to a negative 4. It reflected and stretched. 0 doesn't change. Negative 1 makes up positive 4 when you multiply by negative 4, etc. So it reflects and stretches. I'd like you to plot those points and then play the recording once you've got it. Okay, so you can see that in red, now I have the transformed graph y equals negative 4 cosine x. I've labeled it. So it's starting to make a pretty neat pattern here. We're going to make one more graph on the same axis. Hopefully that's not too much for you. And this final graph we're going to look at is 3 halves cosine x. So 3 halves, well, we're going to basically consider that 1.5. And multiplying by 1.5 is going to have the same effect as multiplying by a positive value like 3. It's just not going to be transformed quite as much. Okay. So in this case, we could look at the calculator if you want. Feel free to. I'm going to take each one of these positive values, and I'm going to make it, use a blue color here. 3 halves is big. All right? 0 doesn't change. If I multiply negative 1 by 3 halves, it goes down to negative 3 halves. It's just not stretched out quite as much as the one where it was 3. Okay? You're going to have a nice graph that looks similar to this. Nice little curve here. Not quite happy with that. Fix that up. And then of course we have to label it. Y equals 3 halves cosine of x. Okay? Why don't you play the recording once you've got that graph. Okay, so at this point I'd like to sort of step back and look at what we've done and write down some conclusions about putting a coefficient in front of the cosine function, whether it's positive or negative, whether it's a fraction or not. Okay. So if you have any space at the bottom, or if you want to use your summary notes, let's write some conclusions about having a coefficient of a in front of the trig function. So let's say if a is negative, think about the effect we saw when we put a negative 4 in front. Hopefully you'll realize that the graph reflects over the x-axis. Same thing it did with parabolas, right? Goes back to all the other functions we looked at, parabolas, absolute values, etc. And if the absolute value of a, we didn't get to this one yet, you'll see it in the sine graph. The absolute value of a is between 0 and 1, like half, say. All right, so let's say the absolute value of a I'm really messing this up. Third time's a charm. Absolute value of a is between 0 and 1. So like a number like half. Graph shrinks vertically. Okay. And again, the scale factor is a. And the other ones we looked at is if it's bigger than 1. So if absolute value of a is greater than 1, I should have put here not equal. I'm going to come back and revise this a fourth time. Sorry about that. Obviously, it's equal to 0. That pretty much wipes out the graph. And if it's equal to 1, that's going to have no effect at all. So we're going to have just greater than symbols there. All right, so if absolute value of a is greater than 1, graph stretches vertically, and the scale factor is the absolute value of a. Okay? In all cases, it never affected the x-intercepts. Okay, so maybe that should be our final note here. The x-intercepts are always the same as the original. Okay. All right, at this point I'm going to give you a task, and I'm going to give you some work time, and then I want you to play the recording once you've got your work done and see how you did. Okay? So this task involves making a sine graph. Okay? So you're going to make a sine graph on the opposite side of your paper. Same way we did the cosine graph, right in the middle of the paper. Then you're going to make 3 different transformed graphs without using your calculator, just using your notes. So 2 sine x, negative 3 sine x, and negative half sine x. Play the recording when you've got those 4 graphs made, including the original one. You're going to make that there. Okay, so hopefully you made a sine graph, y equals sine x, that looks like that, and your axes are set up nicely like mine are. Lots of space in the y direction to make more transformed graphs. Come back when you have more graphs added. All right, I've added the graph y equals 2 sine x. I'm going to put a label in here. Okay, come back when you've added negative 3 sine x. Okay, hopefully you've graphed and labeled y equals negative 3 sine x. Hopefully you're taking your time making nice graphs, something you can be proud of here. All right, last graph I'm going to have you make is y equals negative half sine x. Come back when you've got that graph graphed. Okay, and finally in black I've got y equals negative half sine x. This graph is vertically shrunk. Its scale factor is half. It's also been reflected in the x-axis. That's it. See you in class.